Hello everyone, this is Wilson. Welcome back to my 1 minute presentation. So today I'm going to talk about carbon monoxide gas distribution or the gas movement in a smoldering fire. So in this series of presentation, I'm going to focus on practicing my presentation skills on how to describe a scientific graph. So let's get started. So the carbon monoxide gas distribution in a space or the gas movement will affect by the gas temperature or the surface temperature of a smoldering fire. So let's take a look at this graph. So this graph is about the carbon monoxide concentration in a space. So the x-axis is the simulation time, and the y-axis is the average carbon monoxide concentration in a compartment space at 2-meter height. So the black curve is the full-scale experimental result from a literature, and the different colors of the curves is the FDS simulation. So if the surface temperature is lower than 140 degrees Celsius, let's take a look at the green curve. So since the carbon monoxide gas, since the thermal buoyancy force due to the temperature differences between the CO gases and the ambient temperature was not large enough, so the gas is accumulated at the ground and leak from a door gap at a constant rate. So that's, as you can see in this green curve, this is a flat curve, and the carbon monoxide concentration is sustained at around 0.1%. So when the temperature reach to 140 degrees Celsius to 200 degrees Celsius, just like the region of the orange curve, so each match with the experimental results. So the carbon monoxide has an increasing trend, and also the peak carbon monoxide concentration is similar to the experimental result. So the experimental result, the peak point is 1.9%, and the 140 degrees Celsius and 200 degrees Celsius, the peak carbon monoxide concentration is around 2% and 1.8% respectively. So those errors may be caused by the uncertainty of the smoldering process. So, and I think this is fine. So 140 degrees Celsius to 200 degrees Celsius is matched with the experimental results. So when the temperature reach to more than 200 degrees Celsius, or let's take a look to a light blue curve. The light blue curve, the light blue curve also has an increasing tendency of the CO concentration, but as you can see, the peak point is different from the experimental results. So we can ignore this curve because the smoldering gas temperature should be less than 250 degrees Celsius. So if the temperature higher than 250 degrees Celsius, the smoldering process will turn to a flaming process, and the flame may occur in this temperature, in the temperature higher than 250 degrees Celsius. This is the end of my presentation. Thank you.